All right, today's lesson, we're going to use coordinates to prove geometric theorems algebraically. All right, let's start with this rectangle. Given the coordinates 1, 3, 2, 6, 7, 5, and 6, 2, prove that these points form a rectangle. Well, first let's start with some facts about rectangles. We know that opposite sides are congruent, right? We also know that all four angles must form a 90 degree. All four angles are 90 degrees. To be a rectangle. And we know that the diagonals must be the same length. But now you have to be careful in geometry. Opposite sides congruent, well, there's some parallelograms where that's true, but they're not rectangles. All four angles are 90 degrees. You could show that. That would definitely make it a rectangle. Or you can show that the diagonals must be the same length. And given that we're given the coordinates, we can figure that out. We can show that the diagonals are the same by using the distant formula. Remember, distance is the square root, and it's the difference in the x-coordinates. We tag it so you know that the order makes a difference when you subtract. Plus, so that's squared, plus y sub 1. That should be subtraction there. Y sub 2 squared. This comes from the Pythagorean theorem. So what we're going to do is we're going to plug these coordinates from here to here. I want to see if that's the same distance as this length. So we're going to use 2, 6. And 6, 2. And put that to the distance formula and see if it's the same as the distance from 1, 3 to 7, 5. Okay, so let's say we start with this ordered pair. This would be 2 minus 6 squared plus 6 minus 2 squared. And don't forget, this is under the square root. So what you're going to get is negative 4 squared plus 4 squared. This will give you 16 plus 16, which is 32. So this is a square root of 32. In order for this to be a rectangle, this segment here has to be equal to the square root of 32. Let's see if that happens. I'm going to use the next slide to show that. All right, we have 1, 3, and you have 7, 5. So you have 1 minus 7 squared plus 3 minus 5 squared. So you're going to get negative 6 squared and negative 2 squared. So 36 plus 4, which gives me the square root of 40. That's not the same as the other. So therefore, the distance is not the same. That's not the same as square root of 2, right? Square root of 32, I mean. Therefore, we can conclude that these points do not form a rectangle. It forms a quadrilateral, but doesn't form a rectangle. Let's try another. Given the coordinates 2, 1, 2, 5, 8, 5, and 8, 1, prove that these points form a rectangle. Again, let's use the distance formula to see if the diagonals are the same length. So, let's start with this one. Here we have 2, 5 and 8, 1. So, I'm going to say 2 minus 8 squared plus 5 minus 1 squared. Don't forget that's under the square root. So you're going to get negative 6 squared plus 4 squared. It's going to be 36 plus 16. And that should give you what? 52. Square root of 52. This has to be the same. So let's see if that's the same. All right, so here's the one we have 8, 5. And then we have 2, 1. So you're going to have 8 minus 2 squared plus 5 minus 1 squared. So that's going to be 6 squared plus 4 squared. It's going to be 36 plus 16. That gives you the same. Square root of 52. Therefore, we can say these coordinates form a rectangle. And that concludes our lesson for today.